Well, hello there. Long time no see. So, have you ever listened to the radio or watched the news and they say things like, it has everyone loves Crest toothpaste, plus or minus 2% of the people. So, that's always dealing with the margin of error. Anytime they say that, they're talking about, we could be wrong. Uh, the actual statistic we are sampling might be above or below with a margin of error. So, what that means is they did a study and they found out that 50% of the people like Crest toothpaste, plus or minus 5%. So, what that means is their margin of error says that, it could be 55% of the people or it could be 45% of the people. So plus or minus a margin of error tells you how far above or below the mean that you have to go to really get an accurate sampling. We didn't ask every single person in the entire universe if they like Crest toothpaste. We just picked a sample, and that's the key. So remember, we're always dealing with a sample. So we want to extrapolate and see, okay, if I was talking about a full-on population, I would be off probably by this percent. And that's what we try to figure out. So, two things that we're going to be talking about today are that margin of error, how the sample differs from probably the actual population. It's just a kind of a guess in a way. And we just want to expand our guess a little to encompass more of the population. And then the confidence interval tells us, which is what I was just talking about right up here. This would be like the confidence interval saying, what if I pick any group of people between 45 and 55% would like it. So that's kind of what this means. So the sample and the mean. So the first way to deal with the margin of error is if they give you the sample mean and the sample standard deviation. So there's two types of margin of errors that we're going to be talking about, and one it depends on what the problem gives you. So and what formula you use is going to be based on what information they give you. So if they give you the standard deviation, if they give you the mean, the sample mean, then you're literally going to multiply the standard deviation by 2 and get 2 standard deviations above and below the mean. Now, we understand what that means, right? It was always that 95%. 2 standard deviations above the mean and 2 below. That's the 95%. That's why this is such a big deal in this class. That 95% is what we want to stay around. So that's why we take the standard deviation and multiply it by 2. Because if I add it to the mean, so in this particular example, the 95% of the population, if the mean is 100, the margin of error is going to be 2 times the standard deviation, or 30. So I'm just going to go 2 standard deviations above the mean by adding 30, and 2 standard deviations below the mean by subtracting 30. And then we could say whatever this study or whatever was studying, that between 70 and 130 would be an accurate statement. Okay, this is the easiest one, and this is the one we always give you, because it really is really straightforward, because you understand the Okay, so with this particular problem, sorry, I edited a little there. We want to find the confidence interval that contains 95% of the population. That just means 2 standard deviations up and 2 standard deviations below the mean. Okay, so the 95% isn't really part of the problem. So to figure out the margin of error, we do 0.463, which is our standard deviation, and multiply it by 2. And that I get 0.926. And then my mean is 0.815, and I just add 0.926, and I subtract 0.926. That's it. So this one would be 1.741 and negative 0.111. Okay, and that will give me the interval. So it's always low to high. All right, so the lowest number goes here, negative 0.111, and the higher number goes here, 4. Okay, and this is my confidence interval. That is so messy. All right, so now we have a second kind of margin of error. The second kind of margin of error deals with the sample proportion. So they don't have the mean and the standard deviation. What they do have is the sample proportion and the total number of people that have been sampled, so they know. It's basically just saying the probability. Okay, so the sample proportion is literally just the probability that an event, you know what I'm saying. That says probability, then an event occurs. I could erase it, but I think that would just take time. The probability that an event occurs. So this is always a decimal. Decimal less than 1. Always, okay? Technically, I guess we could say between 0 and 1. So it's always a decimal between 0 and 1. Okay, because 0 and 1 would both negate this sucker. So n is the number of people sampled, so that's your n. And the event, the people in the event, divided by the total people, which is technically the probability. Okay, and then we just do the same exact thing we did before. This sample proportion, which is our probability, plus or minus our margin of error, and get our confidence interval. So this is the second kind. So let's look at an example with that. So a nationwide poll was taken of that 14,032 teenagers. Okay, this is extra information. Who has a TV in their bedroom? 630 said that they have a TV in their bedroom. Okay, so what's the probability that if you pick any student out of these 1432 that they have a TV in their bedroom? Well, it's 630 over 14 over 32. That is it. Okay? So we just get that number. That's 0.4399. That's the probability. So they said to the nearest tenth of a percent, so it's 44%. Oh, 44.0%. Okay? Now, using your answer in part A, that's nice because they want us to use this one, not this one. So we'll use the 44% to determine our margin of error. So you can see your margin of error up there. The formula is 2 times the square root of P, 1 minus P, over how many people. So it's 2 times P. So it says 44%. That's the answer I'm going to be using. However, remember, it has to be a decimal between 0 and 1. So I do have to, multiply that and put it in as 0.44. Okay, and then 1 minus 0.44 divided by 1432. Okay, when I do that, I get 0.026, etc. 653, and I multiply that by 100, and I get my percent. So it's 2.6%. So my margin of error is 2.6%. So this is a sampling. And then this tells me how much I might be off if I go to, say, another district or another, if I go to a specific place and I want to kind of guess how many people, teenagers, have TVs in their room. Okay, so what's my confidence interval? So my confidence interval is my sample proportion, which is my 44%, plus the margin of error, and my 44% minus the margin of error. So, okay, so this is the same as the other one on the back or on the front of this paper. We're simply, instead of adding to the mean proportion and subtracting the mean, we are adding or subtracting the sample proportion. So this one is 41.4%. Oh no, that's this one. This is 41.4%. And the other one is 46.6%. Okay, so our interval would be 41.4 to 46.6. So this is telling us the percent of people. If I went to a different place and I wanted to guess, make an educated guess as to how many teenagers have a TV in their room, this would be a good guess, somewhere between 41.4 and 46.6%. So that's what we're doing here. So in Middle Country, let's say there's 5,000 13 to 18-year-olds. How many of them are in the room? So what that means is this is a percent, and I want the number, or the how many. So I simply take 0.414. So I want the decimal equivalent and multiply that by 5,000. And I take the 0.466 and multiply that by 5,000. So instead of getting a percent of people, I'm getting a range of actual numbers of students. So the range, if I were to say, with any degree of accuracy, somewhere between 2,070 and 2,330 teenagers in Middle Country have a TV in their room. So Chris guessed that 1,500 students have TV in their room. Okay? And Vincent guessed that 2,200 have TV in their room. Did either of them have a plausible guess? So is that either one of those possible? Chris is not possible. Okay, unless there's some weird unforeseen circumstances, because his guess is not in the interval. His guess is somewhere over here, so it's beyond 2 standard deviations below the mean. It happens less than 5% of the time. So it's really not a possibility that 1,500. Okay, Vincent guessed 2,200, and his is more plausible because it falls within 2 standard deviations of the mean, because it's in the interval 2070 and 2330. Okay, so we're going to practice some of these and hopefully you'll understand that better. Have a great day.